Hello, my fellow code toasters. Welcome back to Toaster Code, the place where your code gets safer, your bugs get fewer, and your ex still thinks that using any is okay. So, this is episode 4 of our TypeScript Masterclass, and today we are diving deep into the world of object and interfaces, the heart of real world TypeScript code. So, if variables are your vocabulary, then objects are your sentences, and interfaces are your grammar rules basically. And trust me, in TypeScript, grammar really matters. So by the end of this video, you will be able to write object types that are clean, maintainable, and strict enough to make your old JavaScript code cry. So let's begin with how to type basic objects. Let's first create a folder for our episode 4. So I hope you remember that how we used to write the object in JavaScript, or let's just give a quick view on how we used to write something like let cars equals to um, maybe I need name of the car, uh, BMW or BMV, whatever you say, model, um, whatever you want to write. I'm just showing you how to write the object, something like maybe 200. So this is how we used to write object in JavaScript. All right. Now let's just quickly jump and see how we write object in TypeScript. So here we will define name of the object. Let's say user, and here we will add all these properties of the object like name, model, speed, whatever you want to add, like name, age. Okay, and we will say that okay, name will be a string, age will be a number, something like that. Then only we will add the value. Like we'll add name will be of type string. Then we will add age will be of type number. Okay, let's add a boolean as well, maybe is active, uh, boolean. So this is how we define an object in TypeScript. Now what if you have to add the value upfront? Then simply you go over here and do this, and here you can do like name, uh, toaster code, then I need my age 25, not 26, come on. Then is active, true, and this is how you mention the you write a full-fledged object in TypeScript, and we call it inline object type. Okay, let me add it over here for you. Inline object type. Now if you will try to add anything else, then it will show an error that okay, this property doesn't exist, no value exists in scope for shorthand property. Either declare one or provide an initializer. And the type checking is still as we are seeing in the TypeScript. Like if you'll try to make it boolean to string, it will show a error. So like a boolean has to be boolean, a number has to be boolean, and a string has to be a string. And this user must have all three properties with correct types. Okay, if any key is missing or one of them is wrong, TypeScript will scream like, let me just remove it, this is active. If I'll remove this, she, yeah, you can see that property is missing in type, yeah, but required in type here. Okay, because if you'll remove this whole part, okay, then it sorry, uh, if you'll try to remove this whole part, now it's okay, there is no error because here you have just uh, initialized a declared object. Okay, so there is no error over here, but wherever you will add the value of the user object, then you have to add all the values. Now what if, let's say, I don't want to add is active, then what you will do, or let's say let's add something else, maybe bio. Okay, and I don't want to add bio always, sometimes I want to add, like wherever you create a profile, you see that bio is not a mandatory field, it's an optional field. Okay, then how you can do it over here? And to do that, we add a question mark over here. Now this is an optional field. Even if I'll not add bio over here, doesn't, it will not scream at us that hey, this is an error. If I will add bio, then to it's fine. Hey, what's up? Okay. So this is how you write an optional field in an object. It's like bio may or may not exist. TypeScript allow you to skip it, but if you use it, it must be a string. Okay, you can't add anything other than string because here we have said that bio will be a string. If I'll try to add a number or anything, no, you can't do that. Or let me just add a number. Still an error. Type number is not assignable to type string. Got it? So optional properties are like dating app bios. Not required, but if you add one, it better not be lie. I mean, people add only lies on dating apps, but it's okay. We are good people. In case you are not able to see it, let me just increase my. The font is increased. Hope you can see it now better. Now, what if you want to add you want to lock a field once it's set, and here comes read only to protect your data like it's your salary slip. Something like, let's say, I want to add an id over here. Okay, id will be of type number, and if I'll do over here id, maybe 1 2 3 4, fine, no error. What if I'll go over here and I'll do user dot id and I'll do 456? It's fine. Okay, but what if I don't want anyone to change this id? In that case, I will add over here read only. Now here, as I added read only here, it's showing me an error that okay, cannot assign to id because it's a read only property. Read only prevents accidental mutations, great for things like id, email, created at, updated at things. Okay, not updated at because updated at is going to be changed. So it's like saying, hey, this is my birth year and I'm not changing it just because I lied on Bumble. Got it? Now let's level this up. Most real world objects are not flat like these. That okay, just add these 4 5 fields and that's okay. They are nested. Let's type a user with an address maybe. Or maybe let's create a new object. Maybe your ex girlfriend or boyfriend's list. I'll do X list and something. I need name. Maybe name will be of type string. She has a name. What's the issue? Okay, sorry. Name, uh, age, number. Then I need address. And in address, there are multiple fields like street, city, country, flat. So our address will be a separate object. So for that, we can do something like this. This will be a nested object. Nested object. Okay. Now in here we can add anything. Like something like street will be of type string. Then city will be of type string again. Then country will be of type string as well, and flat will be of type number. Fine. And this is how you define a nested object. And if you want to add value, then add something like this, or maybe later on you can add, doesn't matter. Let's add value. Okay, let's add the value of front. Maybe I can do name Sarah. All right. What else we have? Age 24. uh, then we have address, street, uh, maybe 1 2 3 4, TypeScript lane. I'm just writing anything. Okay. City, cheat villa maybe. That justifies. Country. um, Cheatistan. I don't know what it is. What I'm writing. Okay, Sarah, if you're watching this, I'm sorry. Flat. uh, 404 not found. All right, fine. Yeah, it's okay. I mean, it's done. We have a nested object over here. You can see TypeScript allows nesting type as deeply as you want. Okay, there is no limit. And if you want to change any value, then you can simply do let's say I want to change the street. Okay, then how you will access it? You will do xlist dot address dot street. Okay, and we will make it um, 404 ts lane. Fine, this is how you can access even the nested properties of an object. And a normal one, maybe age, if you want to change, then you can simply do this uh, xlist dot age. I can do maybe 25, and this is fine. This is how you can access it, and it's working fine. Let's print all these. Okay, console.log maybe xlist, and I'll do over here xlist, and then console.log users user. Fine. Let's add export. Let's run this file and check its output. Okay, I'll jump to episode 4. Okay, and tsc object.ts. Yeah, we have the javascript file over here for this. Let's do this. Let's run this. Node object.ts. Oh, sorry, object.js, not ts. And here we have the values. You can see we have the x list Sarah 404 ts lane because we updated over here. You see ts lane, and we changed the age as well of 25. Here we have age 25, and this is the users object. I mean user object, but here we have written users. Okay, this is what it is printing. One it's the same 1234 toaster code age 25 is active true, and bio hey what's up. So till now we have covered typing basic objects with inline types, optional and read-only properties, and how to safely handle nested structure. But typing objects manually every time can get messy and repetitive, and harder to manage at scale, bigger scales as well. So that's why now we are going to see the real superhero of TypeScript, that is interfaces, that is reusable, clean, and strict. Okay, let's go. Let's create a new file maybe for interfaces. Interfaces.ts. Fine. So typing object manually works. I mean, we just did. It works fine until it doesn't. When it will not work, when like there will be a lot of mess and nested objects, and you will have to use something similar kind of object again and again. Then you have to add repetition in that. Okay, so every time you copy paste the same shape, and an intern will be crying that why I'm doing this again and again. So let's make our types reusable, readable, and scalable with interfaces. All right, so an interface defines the shape of an object like a contract. Once signed, your object must obey it or TypeScript throws hands. Yeah, TypeScript will just slap you, man. So let's see it. Okay, I don't know why I'm decorating my file like girls project files. Sorry, not generalizing. So this is how we meant write an interface. Just use the keyword interface. Okay. If I'll do interface, I'll do user, and here I'll do name of type maybe string, uh, age of type number, and is active of type boolean. So interfaces are capitalized by convention. Okay, this is a convention people follows, that you have to use the first word as capital, first alphabet as capital. Okay, in interface. So here user is an interface. You can reuse user anywhere now. Okay, this is not any object now. This is a type of data now. I mean data type now, just like a string, number, boolean, same like this. It helps with consistency across your code base. How you can use it? Let's see. So simply like I'll create a value, maybe user1, user1, and user1 will be of type user. I told you now that this is a type of data type. It became now something like that. I mean in lame word I'm telling you. Okay, don't think that this is a data type. So and here now I can add all values, like name will be toasted, uh, age 25, and is active true. See, now if you want to make something another user, you don't have to define this again and again, just like we used to do it in object. If you want to make again another one, you can simply do const user2, it will be of type user, and you can put all these values something like this over here. Because if you not add all these three, then it will show an error. Here you can see type, the object is missing the following properties from type user: name, age, and is active. If I'll add all these three, it's fine now. Toaster head, the second, uh, okay, age maybe 2500, I don't know. So this is how you can use an interface. Interfaces are like a resume. If you say you are a user, TypeScript expects you to have these exact qualifications: name, age, is active. It has to be there. When you are saying that okay, user one is of type user, it has to be all three. It has to contain all three: name, age, and is active. Now if you want to make anything optional, then and read only, then same rule applies over here as well, just like we did in our previous file. Like maybe I'll do, let's add id over here as well. Read only id of type number. Okay, now let's add number over here, maybe, sorry, id 123. Fine. Here also I have to add now id 400. Fine. Now let's add an optional field, address, uh, address of type string. No error because this is an optional field. If you want to add address, you can add address, 404 not found. All right, here this address is optional and id is read only. Optional field means it can't be omitted, and read only means it can't be changed after assignment. Okay, once I added the value, now I can't do something like user1 dot id, it's showing me an error. Okay, cannot assign to id because it is a read only property. Doesn't matter if you, even if you are trying to add number only, it doesn't matter, you can't add. Read only is like your college degree. You don't change it every year unless you lied about it, in which case it's not TypeScript's fault, right? Now let's level up. Just like with inline types, you can nest interfaces too. Let's add a interface address maybe. Okay, interface address, maybe a street. Street will be of type string. Then city will be of type string as well. So this address is an interface now. Okay, we have already added it as a optional field. Okay, never mind, it's fine. Now how we can let's remove this, otherwise it will be a very confusing thing. We can make maybe age optional. Fine. Now let's clear the file bit. Now what if I want to add this address interface inside this user? How we can do that? Then that's a very simple thing. You can simply do this, which we had already done. Address of type uh, address, and now this address is of type interface. Let's add optional field so that it will not throw us any error. Or if you want to add address over here, you can simply do this by doing address, same street, anything, city, something. This is how you can add the address again. And this is an address is an interface over here. Now what's the benefit of this? It's the separation of concerns. Let's say tomorrow you want to change the address interface and you also want to add a flat number as well. Then you don't have to go and change the user interface again. You can just change the address interface and it's done. Wherever we are using this address interface, it will the change will reflect everywhere. And now we are not writing this street and city again and again in every user case, every user object. Okay, we already defined that. Okay, street and city will be of type string. We don't have to mention it again anywhere. So we are it's like separation of concerns, code reusability, and cleaner code as well. We are not writing the same code again and again, so our code is cleaner now. Okay, if you don't want to add optional, it's fine. I mean, I just added optional so that I don't have to type it, but now I typed it, so doesn't matter. So nested interfaces are like families. You can ignore some members, but TypeScript never forgets that they exist. Now there is another case. Imagine that you have an interface user and an admin is just a user with some extra powers. So do we repeat everything, that whatever in this user we will paste, copy paste all this in admin and add some extra field in the admin? No, that's the beauty of interface. You don't have to write anything that is here in the user again, and it's very simple to do that. We can simply do interface maybe student, sorry, student, and here I'll do email of type string, password of type string. Fine, we have an interface student. Now what if I need an another interface admin where I need email and password as well? So I will not create this, I will not write this email and password again in the admin one. I can simply do that interface admin extends, okay, extends user interface, and here I will simply do is admin and maybe boolean. Now my admin interface has email, password, and is admin. I'll show you. Let me add the values. All right. I'll do const admin1 of type admin. Okay. This is how we write it. And here, what I need, you can see over here as I'm hovering it, it's showing me that is admin, ID, name, and is active. Sorry, not user. I need student. Now if you'll see over here, what it all missing is a admin of is admin, email and password. These three we are missing. So we have to write over here um, email of type any@mail.com, password 1234567 8, and is admin maybe, yeah, true. So you see, we didn't wrote the email and password again in the admin interface. We extended the same student interface over here. Admin now has all fields from student plus is admin from this admin interface. You can extend multiple interfaces, multi-level inheritance works over here. And these all work super fine. Like if I'll simply do console.log, I need admin, and here I will do admin1. It's fine. And let's print user1 as well. Console.log user, and I'll do user1. Let's add exports just to be on the safer side. We will remove this export in the next coming 2-3 videos, don't worry. Okay, here I can go and do not objects.ts. I need, oh sorry, I have to put it inside this episode 4. Yeah, please move. Oh, interface.ts. We have the it's transpiled JavaScript file over here. Okay, if you'll see, you will not find anything that we have wrote over here in the TypeScript. These one will not be there because these all are just runtime in TypeScript only, not in JavaScript. Here when we transfiled our file in JavaScript, they are gone. Okay, so TypeScript is only till runtime. So let's run this. Let's run our interfaces.js. Maybe interfaces.js. And here we have admin any@mail.com, password is admin true, and this is the user 123 toaster head 25 true, address. Everything is working super fine till now. And interfaces are not just for variables, you can use them to type function parameters too. But since we have not discussed about how to write function in TypeScript, so we will skip this part. When we will discuss the function, then at that time we will see how we can write the interfaces in functions as well. Okay, so we have mastered the interfaces. I hope you did. If you have any issues, any questions, just put that in the comment section, or you can join the our Discord. Link will be in the description of the video, and you can talk to me on the Discord over there, and we can fix your issues or your doubts, whatever it is. So now let's meet their twin siblings. That is type alias. Type alias. It does many of the same things with few extra tricks up its sleeves. It's same like interface, but a bit different. Just like we did over here, sorry, not over here. Why I am writing in the JavaScript file. If I'll go over here, something like we created an student interface and we extended that. So admin is same as student with some extra properties. Something like this, something like over here in type alias, it's same like interface with some extra things. So how we create a type alias? Something like this, like you write type users, and here maybe let's type name, string, age, number. That's it. This is how we write type alias. It's just like interface, but you can define a shape of the object. You can reuse this type. You can use optional read only, nested, etc. over here, just like interface. Okay, A type is like an interface that never went to law school. It still does the job, just like a little more chill. So let's see where this type gets spicy. Okay, it can do something called intersection, where we merge multiple types together. Let's see, something like type has name of type, name is of type string. This is one type, or you can say one, if you are trying to understand it with the context of interface, then say that this is one interface, okay, of string. Let's create another interface, I mean another type, but just for you to explain, I'm saying that, let's create another interface. So here I'll go type as age, and here I'll do maybe age number. Fine, we have two different interfaces, I mean two different types. Now what if I need just one, where I can include both of these, something like I'll do type new user equals to, now here I need both has name and has age, two different types or interfaces in one, this new user. Okay, how we will do that? Has age and has name. Now my new user type has both has age and has name, two different types. If I want to add any values, something like this, I'll do const uh, new user one of type new user, and here I can add name, which is of type string. Toaster again, I can add age 25. Now what happened over here exactly? So I just combined multiple types into one, which you can't do in interface. Got it? It's great for composing complex types from smaller ones. Okay, this is one smaller type, this is another smaller type, and they both are of different, one is of string, one is of number, and we made a one type new user from these both. Here we just did intersection types are like Indian marriages, basically two family comes together and the result is a user who now has both name and the age. And interface and type are so like similar and into each other that you can even like extend the type of using an interface, like let's see, let's create a type base equals to uh, id and number. Okay, this is a type. Now I want to extend this type into an interface. How we can do that? We will do interface, maybe a teacher, interface teacher extends base, and we will do this. Okay, interface teacher extends base, and here I'll do name of type maybe string. Now this teacher has the base and the name. If I'll try to do um, const t1 of type teacher, I can write name of um, any name here, and the id as well. Id will be of type number 123. So see, we just extended the base type into the interface. So interfaces can extend type, useful when you are mixing legacy code or combining styles. This is TypeScript way of saying it's okay to mix tab and spaces if you do it cleanly. Okay, if you do it cleanly, don't mess it up. So interface is basically a shape, it's not an identity. Okay, so you might be wondering like when you should use interface and when you should use type. Okay, So I have written a very good comment for you. Here you see interfaces versus type. I have explained it as much as I can here. I will push this episode 4 file on the GitHub. Okay, you can find the GitHub link in the description of the video. Now what it is, so you should use interface when you are defining a contract for objects or classes, or you need an extension or inheritance, then you should use interface. Okay, but use type when you are combining things like we did over here, where it is here. Okay, you want or use type when you want literal unions like admin user. Okay, in that case you should use type. And you want flexibility with more complex patterns, in that case you should use type. It's not which is better, it is what solves your problem better. So just don't overthink it. Use either, use just never use any. That's the real villain here. Okay, so both are great, pick based on your use case. Okay, and that's a wrap on episode 4 of TypeScript Masterclass, your one stop crash course on everything related to object interface types and how to write code that won't backstab you 2 weeks later. So, we covered inline objects, optional and read only properties, interfaces and interface extensions, type alias, intersection. Okay, and the ultimate showdown of type versus inheritance, interface. So if you found this helpful and your objects are now in therapy and behaving well, then smash that like button, subscribe for more masterclass episode, and drop a comment below. What's the wildest object you have ever passed to a function? I want to hear your horror stories. So this is Trust Code, where we write clean code, avoid any and roast everything else. See you in the next episode. Peace out.